Alright guys, so in the last video, in yesterday's video, I talked about factoring when 1 was here. Well, now we have something other than 1. And that's going to, I showed you those steps before, you're going to really see them come into play now. Alright, so it says students will review factoring when A is greater than 1. How is factoring when A is greater than 1 similar to factoring when A equals 1? And we're also going to talk about how it's different, right? How it's similar. Process is still the same. Okay, process is exactly the same except for this number now matters. Okay, so we're still going to multiply here. So 7 times 4 is 28. So I need factors of 28 that add to 29. Alright, this is easy. 1 times 28 is 28. 1 plus 28 is our 29. Alright, so I don't have to go any further. So, the way this is going to work, I'm still going to put my x here. I'm still going to put my x here. I'm going to have plus 1. I'm going to have plus 28. Now what I have to do is I have to divide each of those by 7. So I'm going to take and divide them by that leading coefficient. Well, 1 divided by 7. 7 doesn't go into 1 evenly, so that means it's going to come up here. So this becomes 7x plus 1. 28 divided by 7 is 4. So this becomes x plus 4. And there's your answer. Alright, so I'm going to do one more with you guys, then I'm going to have you guys pause it and try it on your own. Alright, so right here, 5 times 6 is 30. Actually, go ahead and pause it and try this one on your own. Alright, so you should have paused it to try this one. So we said 5 times 6 is 30, so we want factors of 30 that add to 13. Alright, so 1 times 30 is 30. 1 plus 30 is not 13. 2 plus 15 is 30. Or sorry, 2 times 15 is 30. 2 plus 15 is not 13. 3 times 10 is 30. 3 plus 10 is 13. Alright, so we got x plus 3, x plus 10. We're now going to divide by the leading coefficient of 5. So 5 does not go into 3 evenly, so it comes up. So we got 5x plus 3. 10 divided by 5 is 2. So we got x plus 2. Alright, so let's try it when there's a minus here. Alright, so 3 times 20 is 60. Alright, so we need factors of 60 that add to, in this case, negative 17. Alright, that's positive, that's negative, which means that they both should be negative. But if you want to find the positive and then just change them to negatives, you can do that as well. What I mean by that. So if I just want to work with the positive factors, 1 times 60 is 60. 1 plus 60 is not 17. 2 times 30 is 60. 2 plus 30 is not 17. 3 times 20 is 60. 3 plus 20 is 23, not 17. 4 times 15 is 60. 4 plus 15 is 19, not quite there. 5 times 12 is 60. 5 plus 12 is 17. Well, I need negative 17. So to change positive 17 to negative 17 is pretty easy. I just make these negative and make these negative, and that becomes negative. Alright, so that means we got x minus 5, x minus 12. We're now going to divide by 3. 3 does not go into 5 evenly, so it comes up. So we got 3x minus 5. 12 divided by 3 is 4, so we got x minus 4. Alright, this one's pretty easy. 2 times negative 1 is negative 2. So we need factors of negative 2 that add, in this case, to negative 1. Well, there are only two pairs of there's only two pairs of factors for negative 2. You either got 1 times negative 2 or you got negative 1 times 2. That's all you got. Okay, so 1 plus negative 2 is negative 1, so that's the pair I'm going to use right here. Alright, so we got x plus 1, x minus 2, divide by 2. 2 doesn't go into 1 evenly, so it comes up. So 2x plus 1. 2 divided by 2 is 1, so we have x minus 1. And there is your pair. Alright, so these are those special ones that we talked about before. Okay, but now we have a coefficient in front. So 4 times 9. The real key here is that 4 is a perfect square and 9 is a perfect square. And if that's true, then we go forward with the next part of it. Okay, so they're both perfect squares. So 4 times 9 equals 36, right? Well, 36 is a perfect square. The square root of 36, we know that 36 is 6 times 6, and 6 plus 6 is 12. Okay, so that means that it all works. So here's how this works. Here's how it works. Since 4 and 9 are both perfect squares, the square root of 4 is 2, and then we have our y. Square root of 9 is 3. Or it can be written like that. And again, that plus is why there's a plus here and a plus here. Alright? Now, this one doesn't work. Alright, we're not going to do that one because that one actually doesn't work. Alright, so we'll do this one real quick. Alright, so 4 is a perfect square, 5 is a perfect square, and we have that difference. So difference of two perfect squares again. So square root of 4 is 2, square root of 25 is 5, square root of 4 is 2, square root of 5 is 5. And that's really all there is to it. When you have the perfect square minus another perfect square, it is the square root of the first plus square root of the last, and also the square root of first minus the square root of the last. And that works every time. So 9 is a perfect square. 100 is a perfect square. The square root of 9 is 3. Square root of 100 is 10. And it applies there as well. Alright, so that's the end of this one. So practice these with the assignment. If you have any questions, let me know.